Good morning, class. Sorry about the confusion. And I'm informed the last slide we looked at was the cycloserine. So I'm hoping we finished on the cycloserine. Did we finish on the cycloserine or we just started? Did we finish everything, mechanism of action? I think we did. Class, did we? Thank you, Cecilia. We finished. Thank you. So even synthesis, we did the synthesis. Yes, thank you. Amina, we did synthesis. I'm told I did not tell you to draw the quinolones. But that's what we have to look at this morning. I unfortunately, when I was just about to send the structures, my computer, I don't know why it's shutting down. But I'll have it checked over the weekend, because you can't have it checked over the week. It might mess you more. So I think quickly I can send you the structures of the quinolones. I hope it will be of, is it of any help if I send you the structures of quinolones? Did it help you at all? Yes, fine, thank you. So I was just about to do that when it shut down. So let me send them very quickly because they are ready. I've just sent the structures. If there is anything that can test one's patience, is these computers. Wow. You can check whether they're in your emails, because I've just sent. You'll be able to receive them. So I think we are done. We are not yet done with the antimicrobial agents. We are still looking at some of the compounds, or that some of the antibacterial agents that can be used. We have looked at quite a number, and this morning I want to see whether we can introduce the quinolones. Again, as we had discussed earlier, the quinolones are used for second line. They are used as second line. That is if you have a patient either who has multi-drug resistance, TB, and therefore they must use an alternative. One of the issues of the quinolones is that, of course, they are a bit more expensive, especially if you use a branded product. If you usually use a branded product like norfloxacin, they are very, very expensive. They used to, initially they were not available because of the cost, especially of course in countries like Kenya. But now we do have generics. But again, because of some of the issues in manufacturing, you might find some of the generics are not well done. But that is a fault or an error of the Pharmacy and Poisons Board, or an error of the governing bodies of the pharmacy, because they are supposed to ensure that a proper testing of these drugs is done before they are registered. But sometimes that doesn't happen. As you continue, as you finalize and graduate and qualify and go out into the market, you realize that there are very many anomalies, mainly because of corruption. But if things were done right, all generics that are registered for use in any country should have good efficacy, just like the branded product. But unfortunately, as I have said, there is a lot of corruption, and sometimes you do get drugs that are registered as generics, and they are not as good as the branded products. Loss. They are not as good as the branded product, but that is because of corruption. And therefore, that is why sometimes you find recommendation of using the original quinolones, because we're already talking about a drug-resistant TB. So if now you use a quinolone that is not highly effective because of poor manufacturing or because of poor SOPs in the manufacturing, then definitely you know what will happen. It will result in death. So that is why you will find that you'd prefer to use the original branded quinolones like norfloxacin, not like noroxin, ciproxin, but they are very, very, very expensive. But when manufacturing processes are followed to the letter, the generics will do also a good job. So when we look at the quinolones, want to look at the quinolones. When I don't have the slides, it has happened. Goodness. The historical background, I don't want to be very loud because of my throat. The first clinical use for quinolone was nalidixic acid. I don't know whether you have heard of nalidixic acid. Nalidixic acid is mainly used as a urinary antiseptic because it has very narrow spectrum of activity. It was generated from chloroquine, an antimalarial agent. It was active against some gram-negative bacteria and had limited usefulness because of its high protein binding and short half-life. Bacteria developed rapid resistant to this agent. So one of the first agents was nalidixic acid, and even now it can be used, but as I have said, mainly used just as a urinary antiseptic because you can see it has some activity against gram-negative. It has high protein binding. It develops resistance very rapidly. Development of better molecules has been focused on the following aspects. One, increasing activity against resistant strains of microbes, anaerobes, and atypical organisms. That is the dream of the objectives of drug discovery and development, always to improve on the spectrum of activity, greater activity against gram-positive cocci and anaerobes. You can see it had some activity against gram-negative, so a narrow, as I had said, a narrow spectrum of activities. You wanted to increase activity against gram-positive cocci and anaerobes, reducing rate of emergency of resistance. Because again, remember the microorganisms, like for TB, the microorganisms we are dealing with, improving pharmacokinetics and pharmacodynamic profile targeted towards selectivity of drugs. So these are very general, uh, uh, very general needs or very general objectives for developing new molecules. These very general objectives or goals and objectives for developing new molecules. You want them to be better. You want to reduce the toxicity. You want to increase spectrum of activity. You want to improve on the pharmacodynamics, pharmacokinetics. And of course, you want the drug to be very selective. If the drug is highly selective, that implies you have reduced on its toxicity. And we can look and we're saying flumequine was the first fluoroquinolone, which was patented. After that, many fluoroquinolones with better activity were developed. So this, you're going to, of course, I don't know whether you have studied the anti-malaria agents. This is chloroquine. That is chloroquine. Of course, chloroquine is an anti-protozoa agent. Chloroquine is an anti-protozoa agent. And then from chloroquine, you can see you have flumequine. And we are saying the fluoroquinolones, they are called fluoroquinolones because of this fluorine, which is in that position, that fluorine in that position, and of course they are quinolones because of this oxygen there, and a double bond there, and double bond there. So the flumequine, that is the flumequine, it was the first fluoroquinolone that was developed, but again, it was found not to be the best, and therefore modification gave rise to other drugs, which we are going to look at. So we have also this one is enoxacin, and you can see when you look at enoxacin, you can see quite some structural difference. You can see the nitrogen here. Even this nitrogen here is substituted with an alkyl group, but you can see also that nitrogen there is substituted with an ethyl group. Again, you can see you have your fluorine just as you have there, but of importance, and as we are going to look at, is the piperazine group that is attached to this number 7. 1, 2, 3, 4, 5, 6, 7, 8. So that piperazine moiety attached at position number 7 was found to bring in a lot of importance, or it improved on the drug activity. And of course, we are going to go through that. So also another drug was enoxacin. So we are only saying that there was structural modification of flumequine to develop better molecules, which had, of course, better activity. Again, the fluoroquinolones, just like other drugs that we have looked at, including the cephalosporins, were classified according to generations. And as we have said, the generation refers, or the criteria of the generation is how new a molecule is, and more often than not, also its spectrum of activities. We have about 4 generations. We have first generation, where we have, of course, the prototype, which we have said is naridic acid. We have oxolinic acid, we have lesoxacin, and we are saying all these drugs are active against gram-negative bacteria. They are highly protein-bound drugs, and they have a short half-life. So that is our first generation, active against gram-negative bacteria, highly protein-bound drugs, and they also have a short half-life. Then you have the second generation, where we have drugs like norfloxacin, very important drug, ciprofloxacin, very important drug, ofloxacin, also a very important drug, also enoxacin. And we can see all these ones now have a slightly lower protein binding. You can see their protein binding is a bit 50%. So again, so they have lower protein binding, they have a longer half-life than previous agents, they have improved activity against gram-negative bacteria. So again here, we have improved on activity against the gram-negative bacteria. So there is an increased, the range of activity has been extended when you compare first generation to second generation. They have also a longer half-life, but most of them, of norfloxacin is given BD, ciprofloxacin is given TDS, so they have a slightly longer duration of activity and better gram-negative activity. Then from there you get to the third generation, and you have sparfloxacin, levofloxacin, moxifloxacin, gatifloxacin. Again, because these compounds have structural resemblance, you can see their suffix is adding oxacin. almost all of them, oxacin, 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 and that shows their resemblance within these compounds. When drugs have the same suffix, either they have the same mechanism of action, they have structural resemblance, and therefore they do have some similarity in their name. Then we have the third generation, sparfloxacin, levofloxacin, moxifloxacin, gatifloxacin. These are active against, again, gram-negative bacteria, but now you can see we have introduced activity also against gram-positive. Of interest is most of the other antibacterial agents are starting with good gram-positive bacteria, gram-positive activity, and we were trying to introduce gram-negative. But you can't see for the quinolones, they are starting with gram-negative, and we are trying to introduce gram-positive bacteria. So the difference here would be we are trying to introduce a a a a, a, a lipid soluble moiety. We are trying to introduce a lipid soluble moiety or a lipophilic moiety within the drug, because remember, when we were looking at the antibiotics one, when we were looking at the penicillins, the cephalosporins, we did mention that when you have lipophilic moieties within a drug, that drug has higher gram-positive activity. If you introduce polar groups within that drug, normally you introduce gram-negative activity without really significantly, I'm using the word significantly influencing the gram without significantly influencing the gram negative activity. So here, please note the difference. The quinolones, we are starting with gram negative activity. We are trying to introduce gram positive activity. So we are not introducing a polar group. We are introducing a lipid soluble group, an alkyl group, a group that will increase the lipid or the lipid partition coefficient. So we are trying to increase the lipid solubility of these drugs so that they can target the gram-positive bacteria better than the gram-negative bacteria. So that is the third generation. Then we have the fourth generation. Mainly, the main drug there is trovafloxacin, and shows extended activity against both gram-positive and gram-negative strains. Whether this can go down, I think that was the best. I move it in a minute, see. It's better when it is small. I think it was cut there by mistake. So it shows extended activity against both gram-positive and gram-negative strains of bacteria, also active against other bacteria like the anaerobes and atypical, usually mycobacteria or typical microorganisms. So you can see we are improving on the spectrum of activity as we increase the generation. And of course, as we have said, we are also decreasing the lipid solubility so that this drug can be more available to the microorganisms. So mainly for generations. Sometimes again, when you look at different different books, you might find some different drugs, just as we were looking at the non-steroidal anti-inflammatories, and we did mention some of the classifications could put like ketorolac as propionic acid derivatives in place of this instead of acetic acid derivatives. But as long as you give the justification, sometimes you find the classifications can differ, and all one requires to do is to be able to give the proper justification. So we are looking at the first generation, and the most important molecule there is the nalidixic acid, and we are saying the nalidixic acid is like the prototype. It is the prototype, and if we look at that drug, we are calling it a quinolone. It has that ketone or oxo group at that position. You can see this, that the bonds, these bonds within the pyridine ring can shift. So they can shift such that you have the bond here, the other bond there, the other bond there. So therefore, we are talking about there is a double bond there, depending on these ones can resonate. The double bonds within the pyridine can resonate such that at one point you have a double bond there, you have a double bond there, you have an oxo group, and therefore that qualifies them to be quinolones. That qualifies them to be quinolones. You can see, unlike the other drugs we're going to look at, this nalidixic acid does not have a 6-fluoro group at the bottom. Look at its position number 6. It does not have a 6 floral group. You can also see at its position number 7, it does not have a piperazine ring. It does have a methyl group at that position. But of importance is that if you look at position number 1 to 3, at position number 3, just like all the other drugs, it has a carboxylic group. At position number 4, it has a noxo group. So that is of great importance, because we will see that this portion here is very important, the pharmacophore. That portion cannot be changed. As we can see this portion, that portion here can be changed. That position there, that position there, at position number 6 here, we can see it can be changed, because in some of them you have a fluorine. We'll also see that that position there can be changed. Of most important, this position here also can be changed. This position here also can be changed. So what are we saying about the quinolones? The quinolones are drugs which have quite a number of positions, which are flexible, and which where you can have different substitutions with retention, or indeed with increase in antibacterial activity, with increase in the spectrum of activity, with decrease in the plasma protein binding, and like quite a number of the drugs we have looked at. And as you can see, the area that seems not changeable is this area where you have the carboxylic group and you have the oxo group there, and you have this position. So this position here seems to be inviolate, a position that is not really changeable, but quite a number of the other positions indeed can be changed. Because if we look at this drug here, you can see this position here, there is the same, even that position here, but I've said this position we can change. You can see here, that group does not change. This group here, you can see this group here was a pyridine ring. This is a phenyl ring, not substituted at all. But you can see at position number 7, you have a pyridine group. Again, remember, these molecules are discovered through a lot of in vitro work, whereby you do the structure activity relationship, and then you check it up. So you develop the molecule, you take it for in vitro work, and then of course later you take it for the clinical trials until you get the molecules that are safe, in other words, minimal toxicity, and have very good pharmacological activity. Again, if you look at that drug, we are saying quite a number. This is now the reversed. Please note, this group here should be on this. When you compare it to this group here is the same group as this one here. So indeed, the substitution is at this position here. So we are saying the quinolones are drugs that whereby we can have a lot of structural modification with improvement of the biological activity. So that first generation. Then we will go to the second generation, where we have said we have norfloxacin. Look at norfloxacin. There at position number 1, you still have an ethyl group. As we have said, this position there is inviolate. That is fixed. We are not changing that group. If we change that group, we will interfere with biological activity. Look at our position number 6. We have a fluorine at that position. Look at position number 7. We have an unsubstituted piperazine ring, because in some of them we will find piperazine ring can also be substituted. Then ofloxacin, again, if you look at ofloxacin again, I'm sorry, this is the other way around. It's been put upside down. So if you look at ofloxacin, you realize that this is our position number 8 here, down here, and you can see this group that has been substituted there. So that group has been substituted there, and that group makes this ring, the quinoline ring. It makes it to be a tricyclic ring rather than a bicyclic ring. So this is a group that has been added at that very critical position. Then you look at ciprofloxacin, because you can see this nitrogen is that nitrogen here, and then you add that group there. So you can see that this is now a ciprofloxacin, again, a very important drug. And what do we see? A new group that is introduced at position number 1. As I said, it's 1, 2, 3, 4, 5, 6, 7. So you can see now at position number 1 of ciprofloxacin, there is introduction of the cyclopropyl group. In most of the others, we was finding with of course exception of fluoxetine, where we have this group which is different. But in most of the others, we had an ethyl group. So we are saying that if you can have an ethyl group, you can have a cyclopropyl group, and we will see the difference when you introduce those different groups. Again, please note that area still the same. This area, again, fluorine, allowing this compound to be called a fluoroquinolone. This is a fluoroquinolone because it does have a fluorine at position number 6. If you look at number 7, again we have an unsubstituted piperazine ring, again with improvement of activity. So that again is the second generation, norfloxacin, and ciprofloxacin. Then we go to the third generation. Again, if you look at this third generation, this one is now drawn better. You should have seen the other one. That this is drawn, is the same way this should have been placed. So this is levofloxacin. And when we look at levofloxacin is a stereoisomer of floxacin. If you look at levofloxacin and floxacin, and levofloxacin have actually the same structure. And the only difference is that levofloxacin is the levoisomer. It is the levoisomer, and therefore, and you see that even when we do the antihistamines, you see that sometimes you can change the stereochemistry. And when you change the stereochemistry of a particular drug, you find that drug is more active when it is in a specific when it carries a specific stereochemistry. So ofloxacin will be will be the racemate mixture, whereby you have the levo and the dextroisomer, whereas levofloxacin will only be one isomer, the levoisomer, and it was found to be more active than the ofloxacin, and therefore qualifies to be in the third generation. Again, as I had said, look at that. This is a group, the same group we were talking about. Fortunately, this one is drawn well. So that's the nitrogen. This is the group that has been joined here. So we are saying at that this group here, what it does, this is a position number 8. It joins position number 8 and position number 1 with this like an ether. So it joins position number 8 and position number 1 with this ether linkage, and therefore, instead of this drug being bicyclic as we had seen with the ofloxacin, it becomes tricyclic. The drug is tricyclic, but of importance, kindly note that that group is still retained. Importance, kindly note that that group is still retained. There's an omission here of position number 7. There must be a floral group at position number 7. Again, now, I hope that is also ofloxacin. We had drawn it the same. Yes, indeed. You can see ofloxacin is not like ciprofloxacin, whereby the piperazine ring is unsubstituted. You can see ofloxacin, the para nitrogen has been substituted with a methyl group, and you can see that's the same case with the levofloxacin. As we have said, it is the stereoisomer, the purified, or the pure isomer of ofloxacin. So you can see now there has been introduction of a methyl group on that nitrogen, unlike the other drugs that we have been seeing where they had unsubstituted piperazine ring. As I have said again, for correction, there is a floral group at that position. Then we look at another drug, the sparfloxacin. Again, here in ciprofloxacin, we are saying cyclopropyl group again introduced at position number 1. The same group retained there. Now of interest, we have a group at an amino group at position number 5. That's our position number 5, and we will see that it has some effect on the photosensitivity. And I think it's only of the examples I have, it's only sparfloxacin that has a substituent at that position. But of importance, again, look, we still have a position. Again, of a lot of importance is that we have our piperazine ring, but it has been now double substituted. It has been substituted position 1 prime, 2 prime, 3 prime, 3 prime, 4, 5 prime. So it is now substituted at 2 positions with a methyl group, and we will discuss the influence of those substitutions on the piperazine ring on the activity. Again, if you look at gatifloxacin, again, we are seeing the same thing there. Cyclopropyl group, we are seeing a fluoro group there, a substituted piperazine ring there, and at our position number 8, we have a methoxy group, again with retention of activity. Moxifloxacin, again, we are settling at a cyclopropyl group there, responsible for a lot of activity. Again, fixed group there. We have our fluoro group there, and a more complex bicyclic ring at position number 7, again with retention of activity. And just like in gatifloxacin, we have a methoxy group at position number 8. So when we look at the quinolones, it is evident that we can have a bit more. They are more flexible when we discuss, structural modification. These drugs are more flexible. Fourth generation